In this video, we will be doing a proof involving equidistance theorem and congruent triangles. So let's get to it. Given xn is the perpendicular bisector of VB, angle ZXV is congruent to angle CXB, prove angle Z is congruent to angle C. So here's the proof, and we will be doing it on the diagram. xn is the perpendicular bisector of VB given. xn is the perpendicular bisector of VB. You don't have to, but if you want, you can extend this down. I'm going to extend it past it just for a visual. Again, you don't need to do this, but if it makes it more clear, you can do it. I'm going to put markings here. Again, these won't be needed, but just so you can see it. Angle ZXV is congruent to angle CXB given. Angle CXV right there is congruent to angle CXB over here. Next, Vx is congruent to Bx, converse of equidistance theorem. Since x is on the perpendicular bisector of VB, it is equidistant from V and from B. Next, Vn is congruent to Bn, again, converse of equidistance theorem. So n is here. It is equidistant from V and from B. Then xn is congruent to xn, reflexive property. A segment is congruent to itself, and it is in both of these triangles to the side here. So then triangle VXN is congruent to triangle BXN SSS, side, 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 side. From there, we're going to continue in red just to try and keep everything as clear as possible because there's a lot of markings on this diagram. Angle VXN is congruent to angle BXN, CPCTC. Corresponding parts of congruent triangles are congruent. So angle VXN right here is congruent to angle BXN over there. And then angle VNX is congruent to angle BNX, CPCTC again. Angle VNX right here is congruent to angle BNX on this side. From there, angle ZXN is congruent to angle CXN by addition. We're going to be adding these two angles and then these two angles on this side. And remember, if congruent angles are added to congruent angles, then the results are congruent. From there, triangle ZXN is congruent to triangle CXN by ASA, angle side angle. We've got these two angles with the circle there. We've got XN, and then we've got angle VNX and angle BNX. So we have ASA over here. Then we'll finish in green. Since those two triangles are congruent, then angle Z is congruent to angle C by CPCTC. So these two angles, Z and C, are congruent, and that is our proof. A lot of markings on this diagram, but if you think through the process and do it systematically, you'll be fine.